My name is Stephan Herbst. I'm responsible for the environmental strategy of Toyota Motor Europe, and I'm going to focus in the next 10 minutes on our ideas how we can achieve zero-emission vehicles in future. First, to set the scene, and it was already said, today we have around 800 million vehicles on the roads, and this is to be expected to increase by around 70% to have around 1.2 billion vehicles by 2020 on the roads globally. This growth mainly coming from China and India. This, of course, imposes a number of challenges for society, but also car industry. First challenge is energy. What kind of energy is available? What kind of energy can we use in future? We need to stabilize and reduce over a long time the CO2 emissions from transport, which currently accounts for around a quarter of global CO2 emissions. And we need to address the issue of air quality, namely nitrogen oxide and particulate matter emissions. We have, as many companies did, looked into different energy scenarios. And as you can see from this chart, we found obstacles for all of them. Just to mention biofuels, which currently has an issue in terms of compatibility, availability, but also sustainability. No wonder our conclusion was and is there is at the moment no strong mainstream candidate. So how are we going to address and how have we addressed this challenge? That's the main reason why we have introduced indeed hybrid technology, because hybrid technology can be combined with every type of energy, be it alternative fuels, diesel, gasoline, or electric. And it helps us also to achieve the ultimate goal, what we call the eco-car, a zero-emissions vehicle, which might be a fuel cell hybrid vehicle, but I will come to this in a second. We have quite a long history of development of hybrid vehicles. We have introduced the first Prius 10 years ago with rather good environmental performance, but we got the feedback that the driving performance should be improved, which we did. It has led to the introduction of Toyota Hybrid System 2, an enhanced environmental and driving performance system in red. After that, in order to realize also scale effects, we have introduced this technology to the Hybrid System 2 to a number of other vehicles. And in parallel, as you can see at the bottom of the slide, we have introduced diesel hybrids, other mild hybrids, parallel hybrids, in order to get further experience with this technology. But not to confuse you too much, just quickly run to explain what we understand, what the difference is between a mild hybrid and a strong hybrid. Hybrid consists basically of 4 components. First is a start-stop technology, then a regenerative braking to recharge the battery when you cruise or brake. A mild hybrid is a system where you have a small electric motor just helping accelerate the vehicles. And the Toyota system is a strong or full hybrid, applying a bigger electric engine that allows to drive purely on the electric mode and can completely switch off the internal combustion engine. Based on all this experience, we have also looked, of course, in the environmental performance and into the cost issues. And of course, strong hybrids are the most costly solution. But we really think that we can't compromise the environment. We have identified this as the best technology with the best environmental performance, and it is our challenge to make this technology more cost-effective by using scale effects and by improving the technology over time. The environmental impact you can see on this slide, which shows the well-to-wheel energy efficiency of current Prius, while a conventional gasoline vehicle has an overall efficiency of around 14%. We achieved 32% with a new Prius. But this is, of course, not the end. And with a plug-in hybrid, we can realize further improvements. I will also come to this in a second. Briefly on the evolution of hybrid units. So first, we have introduced it into the market, and then it's the Toyota way to continuously improve the technology. For example, the electric engine, we have increased the output of 300% since we have introduced this. We have improved the output of the inverter, the power control unit, by 6 times since we have introduced this technology. And we have improved the battery capacity by 50%. So all this has led to a situation that since 2003, since we have introduced Toyota Hybrid System 2, really we could see an acceleration in hybrid sales globally. In 2007, we sold 1 million hybrids globally. Today, we have sold more than 1.4 million, and we have sold just 1 million Prius today. We are looking to reach the sales of 1 million annual sales in the 2010s of hybrid globally. Also, in order to make this happen, we went one step further because hybrids obviously still use hydrocarbons. In order to develop this further, we have introduced plug-in hybrid technology. Again, the key components of a hybrid stays the same, but the electric engine is bigger and also the capacity of the battery. And this car can be charged overnight with a household electrical grid. The main advantage of this vehicle is that usually majority of people drive 20 to 30 kilometers per day. So if you have a vehicle that can drive this distance purely on electric mode, then we can show quite significant reduction of fossil fuels and also CO2. CO2, of course, is, and as John already has mentioned, very much dependent on how do you produce electricity. And this is a well-to-wheel analysis we have done for plug-in hybrids for United States, Japan, and France. In United States, mainly using coal to generate electricity, we saw a small reduction of around 4% in terms of CO2 compared to current Prius, while in countries like France with low CO2 emissions coming from nuclear, also in Sweden using renewables, we can achieve a CO2 reduction by 45% compared to current Prius model. I mentioned at the beginning, air quality is an important issue, and with plug-in hybrid, we will be able to almost zero-nize also nitrogen oxides emission. Current Prius is at less than 0.01 grams per kilometer. Plug-in hybrid will allow us to go even less. As I said, we have some vehicles in the United States, in Europe, and Japan. In Europe, we have a partnership with Électricité de France, where we currently do tests. The current model still has a nickel metal hydride battery, has a driving distance at the moment of 13 kilometers and can go up to 100 kilometers per hour. As of next year and in 2010, we are going to introduce a larger fleet in Japan, United States, and as well as in Europe, equipped with lithium-ion batteries. A more advanced technology, but again, this shows how important hybrid technology is for Toyota, is the fuel cell technology. As you can see from these slides, again, all the hybrid components stay the same, the battery, the power control unit, electric engine, but we just have to replace the internal combustion engine by a fuel cell stack in order to get to a fuel cell hybrid. Sounds easy, in reality it's more complicated and costly. But the basic thinking is really to develop further the hybrid technology in this direction. We have leased so far 33 fuel cell vehicles globally in the United States and Japan. Last year we did a test. We went from Osaka to Tokyo, traveled 560 kilometers without refueling, and we are really seeking for the future commercialization of this technology. But hybrid is obviously not the only technology Toyota is looking in. This year we will introduce the IQ, which has a weight of 860 kilograms, and on the right-hand side we find a number of technologies that allowed us to achieve this. And with this car we will achieve emissions as low as 100 gram CO2 emissions. We also showed a further study, the 1X, a car where we realized 420 kilograms, applying a plug-in hybrid, including FFE application. So we are really working further in weight reduction. And what was also mentioned should be visualized, and this we also just have to not have to work on the vehicle side, but also to think how to organize our future society in fast-growing megacities, in aging societies, and therefore ITS definitely is an issue we need to look into. But also, and as I understand, this is an issue to be discussed this afternoon as a workshop, includes also urban planning issues. Just one example, We have shown the iReal. This is a pure electric vehicle. At the moment, with the acceleration, you can drive up to 30 kilometers with this. A different type of mobility for aging societies also helps to decrease the environmental footprint. Let me conclude. So we are rather experienced. We have sold a number of hybrid vehicles. We are further going to develop this and also introduce new efficient technologies. One focus point of this is weight reduction, and we are also studying to introduce new mobility system. For policy recommendations, really in order to make this happen, we need the increase of public awareness through technology-neutral policy measures, including the incentives for CO2 efficient vehicles. When we think about plug-in hybrids and that we will come, the transport sector and electricity sector comes closer together in future, we need to think not only to set about biofuels target, but renewable energy targets for transport. And of course, we need a further support and study of infrastructure, urban planning issues, requirements, and other mobility options. Thank you very much.